Question number 5 in 15B. Two students are known to have an equal ability at playing an electronic game so that each of their scores are normally distributed with a mean of 25,000 and a standard deviation of 3,000. The two scores are independent. Beautiful. Because they're independent, I can say that the mean of student A will be 25,000 and the standard deviation of A is 3,000 and the mean of B is 25,000 and the standard deviation of B is 3,000 because they have equal ability. So they'll have equal performance and equal variation. What's the probability in a particular game the students will differ by more than 7,500? Okay, so I'm going to call the difference is going to be the name of my new variable. Notice that before I used C being the combined score. So the difference of the two variables will equal A minus B. Therefore, if I'm going to say that D equals A of A plus B of B, then A equals 1 and small b is equal to -1. So I've got 1 times A plus -1 times B. And I'm interested in that the probability of D being bigger than 7500 plus the probability of D being less than -7500, because I don't know which one's going to be the biggest score, whether A or B will be the biggest score. But I'm interested in the difference being more than 7,500. Okay, so the expected value of D will be 1 times the expected value of A minus 1 times the expected value of B. Therefore, 25,000 minus 25,000, my expected value would be 0. Since they have equal ability, then I'd expect that the difference between the two of them would be 0. So I've got D being a normal distribution with a mean of 0, and the variance of D will be 1 squared times the variance of A plus -1 squared times the variance of B. Notice that for these rules, that it's the variance of the first one times its multiplier squared and the variance of the second one times its multiplier squared. So in this particular case, even though A minus B, I'm going to add the variances together. And of course the variances is 3,000 squared plus 3,000 squared, which will give me, don't know, what will it give me? 2 times 3,000 squared equals that, and then I take the square root of that answer, and it gives me that value as the, if I was in standard, it would be something along the lines of 3,000 root 2. The standard deviation of D is 3,000 root 2. So, what am I after? I know that D is now normally distributed with a mean of 0 and a 3,000 root 2 squared is my variance. And here is my D. I'm interested in 7500 above. That is, the difference is bigger than 7500, or I'm interested minus 7500 below. Therefore, it's 2 times the probability that D is bigger than 7500, which is 2 times normal, CDF, 7500 to infinity, where the mean is 0 and the standard deviation is 3,000 root 2. So on my calculator, I might grab a copy of the 3,000 root 2 jump into interactive distribution continuous normal CDF. The lower is 7500, the upper is infinity. My variation is that, and my mean is 0. And that gives me 2 lots of that. So times by 2 is going to be a probability of 0.0771. Being the probability of the difference between the two players is more than 7,500. Is that okay with that question?